Okay, 3.1. Let's talk briefly about 3.1. This is investigating quadratic functions in vertex form. Investigating quadratic functions. Who knows what a quadratic function is? What sets a quadratic function apart? Anybody? Yeah?
Wasn't it like y equals
Okay, x squared. You said x squared. I like that.
X squared, there's
I like that.
something ax and y?
Okay, there's three functions listed here. One of these is a quadratic function. Which one?
Oh, the middle one.
The middle one with the x squared. Perfect. Okay. So anything that has an x squared and the squared is the largest exponent. Okay? That's the maximum. X cubed, this is not a quadratic. Even if it has this, even if it has that, that's not a quadratic. This is a cubic function. The largest exponent dictates what degree the function is. Okay. So now we've got that out of the way. A quadratic function is listed here, a function whose value f of x at x is given by a polynomial of degree 2. That's fancy wordage. You like wordage? That's fancy wordage for the largest exponent is 2 on any of the variables in the list there. Largest exponent 2. Awesome. Okay. A parabola. This is the shape of a quadratic function. Now, I don't know if we need to go back to function here. I can talk about function, but a function is a relation that passes the vertical line test. So that means that this is not a function. Okay? It cannot double back on itself. Each x can only have one y value partnered with it. That's not a function. So this is a function. This is a function. Okay? Any of this is function. If it passes the vertical line test, only passes through once, then it's a function. Okay? If you need to ask me about that later, you can. You can look that up later. But a parabola is the shape of a quadratic function. And here's a parabola. It's not a U. Okay? It's not a U like that. This does not go straight up and down. This is angled slightly, okay, always. It's a function, so it can't go straight up and down. It comes to a curved bottom. It's a parabola shape. Okay, you like that? Thank you. It's a little bit fuzzy, but it's a nice problem. So it's a symmetrical curve that the graph of a quadratic function creates. And it could open up like a cup, or it can open down like a, come on, up like a cup, down like a, down like a tree. Oh my goodness. Okay, if your tree looks like this, I suppose that this could be a parabola. Okay. That is obviously not the word that I was looking for. Up like a cup, down like a... Like an upside... Frown! Thank you. You are a genius. Extra credit. What's your mark right now? 98? 100. That's what it is. I'm just assuming it's 98. Probably. That'd be nice. Okay, up like a cup, down like a tree. Okay, we'll remember that. You guys make my life so difficult. I'm just saying. No, I'm just kidding. I'm just kidding. You're welcome. Okay, the graph of a quadratic function is a parabola. Where is the vertex? It is either the lowest point or the highest point on the parabola. Okay? You guys good with that over there? Okay, vertex. It's the lowest point on a parabola that opens up like a cup. It is the highest point on a parabola that opens down like a tree. Okay? The minimum value of the function. Well, this parabola, this quadratic function has a minimum value, and that occurs at the y value of the vertex, the minimum. You think about this. This is not a minimum. That's the x value of the vertex. The y value of the vertex would represent the minimum. That's the lowest point on the horizontal, right? The y. The maximum, well, if you have a parabola that opens down like a tree, then there's a maximum point. That's the y value of the vertex. Okay. Remember domain and range? Domain is x values. Okay. Domain is this way. Part of the domain, you think about the x values. The range is the y values. So how high does it go? How low does it go? That's the range. Domain, range. X domain, y range. Okay. Good with that? Yeah. That's right. Just put it to music, and you've got your own little math dance move there. Okay. That's right. Ooh, yeah. That's right. Break it down. Okay. All right. My daughter's going to be so embarrassed when she sees this. Okay. Parameters. Okay, I have a quadratic function. Parameters. Now, if we take an x squared, if we take a regular old x squared, what does a regular old x squared look like? Well, it would look something like this. Right? It's a parabola that opens up. It's a parabola that has a vertex at 0, 0. Now, I don't know if you knew that before, but that's what an x squared looks like. As soon as we start messing with the parameters, that is, adding, subtracting, multiplying, dividing, to the x, to the y, to the whatever, we start to change the position and the shape and the orientation of the parabola, okay? So anything that I do to change this, if I were to do plus 2, that's a brand new function. What that changes is what? Does anyone know this? Or would anybody have a guess? I'm not sure what your background is here on this. It moves it up. It moves it up on the y-axis by 2, yes. It moves the whole thing like this. It moves it straight up. That's what the plus 2 outside of the x squared does. So it goes like this. Same parabola, moves it up 1, 2 units. Got it? All right. Now, there's other things that can happen. What are the other things? Well, we could have a 2 here multiplied by x squared. So what do you think happens here? Sorry? Does it get wider? Okay, so you're thinking about this thing here, the wider, okay. It does affect the shape, yes. Now, wider, do we agree or disagree? It's a good one. It's a tough one. Notice I don't have any brackets here. The brackets would be, in order of operations, remember BEDMAS? You would actually do the exponent first, then the multiplication. So if there were brackets here, they would be simply here. So this is a 2 that's multiplied by the former, this here, right here. This is the y value. So it's really like 2 times the description of what y is. So that actually is a parabola that gets narrower. When we have an a value, this is what a is, the parabola gets narrower. Why? Because each y value, so if I zoom in here, it's a bad drawing, but each y value, this is this value right here, it gets multiplied by 2. So it becomes there. So everything goes, it stretches, pulls it up. Okay. What are some of the other parameters? Let's just start working through them. I think there's some examples I think would help here. So a is the one that we just talked about. The a value it stretches. It's a vertical stretch. So it the value of a can be determined. Anyways, it's the vertical stretch. We'll come back to this. Now, in a normal lesson, this is kind of a mini lesson just for today, but in a regular lesson, I would have you graph each one of these. With Desmos, with the graphing calculator, we would graph each one of these to see what happens when we change the parameters. And we're going to talk about this a value. So here's the a. Let's talk a little bit more about this. X squared is just like this. If it has a 1 for an a value, then it's called a normal width. Normal width. That means it's not considered narrow, not considered wide. It's normal. What does normal actually mean? Well, if you start at the vertex, you go over 1 unit and you go up 1 unit, you would land on the graph. That's what normal width is. The a value is dictated by how far you move after you move over 1 unit. How far do you have to move? This is the a value. Over 1, up a. Over 1, down a. Would be a negative a. So here we go. A negative x squared. Guess what? That is a parabola with a normal width that opens down. Negative a. And why is that? Well, all the y values, if they're positive, they get flipped to negative. So this y value, let's say it's a positive, I don't know, 4, gets flipped to negative 4 right here. Okay? Negative. It's outside of the x. Outside of the x squared. Okay, so 2, we said, stretches upward. All of these, this y value gets doubled. This y value gets doubled. This y value gets doubled. So you end up with a parabola that is stretched upwards. So it looks narrower. But it actually gets pulled up. Looks narrower, gets pulled up. Negative would be narrower but down, -2 for an a. What about half? Well, if the a value multiplies the y values times the a value, then if it's a half, guess what? I'm going to start over. But this normal parabola, okay, like this, oh my gosh, the normal parabola, all the y values, instead of doubling, get reduced by a half. So it's like they get shrunk down. This one, half. This one, half. This one, half, and so on. Half. And so you have a parabola that is a bit wider. Okay? So A affects the vertical stretch. Larger than 1, stretched up, narrower. It doesn't move up, but it just goes narrower. And then if it's between 0 and 1, it gets flattened. Negative flips.
Like 2.
Oh, well, okay, is it like rise over run? That's a tricky question. Not really. Not really, because this is it's a quadratic, so it's not a straight line. There's no slope to the line. The A value that I mentioned, if you go over 1 unit and then up, you always go up A units. So in a sense, if we have a run and a rise, you can think of it that way, but there is no real slope for a parabola in that sense. Until you get to calculus next year, then we'll talk about slopes of tangent lines. Amazing. Awesome. Okay? Like, amazing. So much fun. All right, we talked about this one, Q. Okay, Q. This is called Q, and it's really small there. Sorry, the font's really small. But Q would be an addition or subtraction outside of this kind of base x squared function, okay, outside of that. And so plus 4 means the whole parabola gets moved up 4 units. Boom, that's 4. Moves up 4. Minus 3 would be moved down 3 units.
So that's just the y-intercept?
Well, okay, if the graph, so we're going to be exploring all sorts of different parameters that move the graph around left to right, up, down, width, flipping, okay, all of those. So if you have just a base y equals x squared, what is this like compared to the x squared? It just moves the x squared straight up. Yeah. This number out here moves it straight up if it's plus or down if it's minus. But what we're going to find here right away is that we're going to combine different parameters. And so we have to do multiple things to the parabola. But I don't think that's quite yet. I think they give you some time. What is this? Pre-cal 20? Yeah. They take their time. Okay, here's the last thing. No, not the last thing, but the next thing. If we have an addition or subtraction inside the function, so right next to x, inside the function, that is the p parameter, okay? And that's different than the q. Notice the q is outside of the sort of the base function. This is right inside the base function, not multiplied or divided, but added or subtracted. And this is how I like to teach this. If you have something that's added or subtracted inside the function along with the x, it literally moves all of the x values left or right. So it's in with the x. It moves the function left or right. Okay? So, yeah, we'll get a, either today or tomorrow, we'll get a chance to play around with Desmos, and you can test all this stuff. But again, this is just kind of a mini introductory lesson to this. I would encourage you to get on Desmos and to try and graph all of these so you can see what happens. And maybe by the end of class here, I'll do that with you. But okay, all right. Now, if I zoom back out. Okay. Oh, right on. Okay, so these are the only 3 parameters it looks like that we are considering up to this point. That's great. We don't mess around with the b here. Okay, awesome. So those are the 3 parameters we're looking at. We're looking at flipping up or down, okay? Up like a cup, down like a tree. And then we're also looking at moving left, right. Okay, that's the p parameter inside of the x. And we're moving up, down. That's the q parameter. Okay? So here's a good summary of what happens. Y equals x squared is the blue. 0.5x squared is the, what is that? Green. So it's every y value is divided by 2. So let's see. That's 9. Half of that would be 4.5. There you go on the new one. This is 2. Half of that straight down is 1. Okay. And then negative flips it around. 3 multiplies everything, the y values by 3 to plot the new ones. This one here is the q. So that just moves up, down, straight up, down, up, down. And then finally the p, which is maybe one of the trickier of the 3. If it's inside with the x. Now, here's the tricky part. If it shows up as x minus 1, that actually moves to the right 1 unit, to the right. So it's kind of opposite, this sign. It's opposite. So if it's minus, this is to the right. If it shows up as plus, it's a little bit counterintuitive. This moves left. Okay, it moves left. The format, the reason why that is opposite, because the format of these parameters, this is called vertex graphing form or just vertex form. The format is that this is a minus in there. So if p is plus, it shows up as x minus p. If p is negative, it shows up as x minus a negative, so it turns to plus. That's why it's a little bit opposite. But do you want to write this down? Vertex form is y equals a bracket x minus p, all squared. This is for a parabola, plus q. And these are the three parameters that we've explored here so far today. A, P, and Q. Okay, so here we are in Desmos. We've got vertex graphing form. You can see that on the left, y equals a bracket x minus p all squared plus q. That's vertex form, or vertex graphing form. And if the q is 0, and the p is 0, and a is just 1, that means we have y equals x squared. 1 times x minus 0 squared plus 0. That means we just have our basic normal width opening parabola.
So does that mean the x
The p parameter moves the x value of all of the points on the parabola, not just the vertex. But we can focus on the vertex, but it changes all of the x values.
Like, is that the value of the vertex?
Oh, yes. The vertex part of this, thank you. The vertex, I understand your question. The vertex part of this would be the actual values of P and Q. Yes, that's where we're going to end. That's where we're going to end on this today. You bet. So that's why it's called vertex form, and that's what I'm getting to. You're absolutely right. So you kind of spoiled the picture, but that's okay. So if I move, if I move P, look at what happens. So this is, oh wait, what? Q. That's Q, I'm sorry. Here's P down here, thank you. If I move P, okay, so this becomes x minus 4. X minus 4 inside there. I have the vertex here. Going to show me? I don't know why it's not going to give me a label. Okay, whatever. It's not going to show me the points. But this is 4, 0. 4, comma, 0. If I move the Q now, let's say I move the Q up to 1. Now, look what happens to the vertex. The vertex is now at the point 4, 1. So this P and this Q are parameters that move the parabola around, and it actually gives you the actual value of the vertex, which is the strength of this form, the vertex form. So to finish off here, oh, I didn't do anything with A. So if I make A larger, look what happens. It gets pretty thin. If I make A less, between 0 and 1, it flattens out there, and then negative flips around. Negative. Yeah.
It's a bird.
Yeah, flying. Ah, it's coming at me. Ah! Oh, it's falling. Ooh. Ah, ah, ah. Boom. Ah. Okay, there we go. So look at this. Here's my bird. Where's my bird? There it is. There's my bird. Look at, oh, big flaps. Boy, it's really getting blown around by the wind. There's another big flap coming. Whoosh! Okay. All right. So this is the fun. This is the fun we can have with Desmos. Okay. Okay. Finally, the point P, comma Q is the dun da da da. Here's a hint. It's got 6 letters.
Vertex.
What was the guess? Vertex? Sorry. Guess again.
Vertex.
Guess again. V, yes. But you won't guess the last one.
Vertex.
W is incorrect. A, yes.
Okay.
Just kidding. T, boy, you guys aren't that bright. So yes, PQ is the vertex. Having too much fun today, sorry. Math class is not supposed to be fun. It's supposed to be hard work. All right, so that's your mini lesson for 3.1. Now, Okay, so this is the type of question which I'll leave you with here. Determine the quadratic function. So what we have to do is identify P, Q, and A. How do we do that? Well, it looks like the vertex is what? That's 5 units over. This is 4 units down, right? So P is 5, Q is minus 4. So we have y equals x minus 5 squared minus 4. But that's only part of the story. We need to find out if there's an A value. How do you find out what A is? Now, is this a normal width opening or not? Well, if you look over 1, up 1, that's where the next point would be on a normal opening width, right here. So it's a little bit wider. What number goes here to make all of these points on the parabola? That's a good question. What you want to focus on here, and again, I'm leaving you with this one, so you can work on this one to finish this on your own. This point right here is known, and so is this point. So this point is 1, 2, 3 units over. On a normal parabola, how many units up should you have to go up once you go 3 units over? Anyone know? Nope.
No,
It's
9.
over 1, up 1. It's over 2 should be up 4. Over 3 should be up 1, 2, 3, 4, 5, 6, 7, 8, 9. You square it, x squared. So this is only up 1, 2, 3 units. So how much has this original parabola been reduced? By a factor of what? Not reduced by a factor of 3, which is stretched by a factor of 1 over 3. Boom. Okay, fine, I did answer for you. So that's 1/3. All right, get out of here. I mean, you're dismissed.